Hello, viewers. Welcome once again to episode number 19, still on static mechanics. And in these couple of episodes, we are picking resultant vectors, forces. This is the third in that regard. So we want to test the hypothesis we laid down in episode 18 or so. The two forces F1 and F2 act on a body. If force 1 has a magnitude of 5 Newton and it is in a direction of 30 degrees, and the force 2 has a magnitude of 8N in the direction of 90 degrees, we have to find the magnitude and direction of their resultant forces. This is a little bit different from the last two episodes we did. Here, the direction of the magnitude of the forces are also given. But in the previous one, it was only the magnitude that was given. So we need to show, let's see if I can manage this place for the diagram. If I have this force, which is horizontal, so I can label one of those forces to be at the horizontal, and that force will be, let's see which of them. Now, if the diagram is drawn with a Cartesian plane, we can tell that this is the north. Moving from the north to this place given 90 degrees. So width of the force is in the direction of 90. Force 2 has the magnitude this in the direction of what? 90, meaning from here up to here. This is where the force 2 will be. So let's say I put force 2, which is equals to magnitude 8 what? Newton. Then I am measuring from the north again to get what? 30 degrees for the next force. So I can measure my 30 degrees exactly here. From here to here is 30 degrees, having the second force, which is called force 1. And that is a magnitude of what? 5 what? Newton. This would have been drawn with a different marker as a color red or something, but let's see if we can maintain this. This is going to be having parallel with the second force. Then here will also be parallel with the first force. Alright, if that is the case, I can have here being the same as 5 Newton. I can have here being the same as what? 8 Newton. What will be the resultant force, the magnitude of the resultant force, which is what we are looking for? So this is this. What do you think will be the angle between the force 1 and force 2? Here is 30, so here up to that place will give you what? 60 degrees. Let's put it this way. 60 degrees. We are looking for this angle also because we are looking for both magnitude and direction of the resultant what? Forces. Alright. So I think we are good. If here is 60, here has to be 180 minus 60, 120. I think all the sides are well labeled now. Let's see. The point of concurrent is going to be O. Let's label here A, B, and C. If I can put demarcation in it. O, A, B, C. I think this make it a bit different. Now, what do? We need a resultant. So let's use cosine rule. So if we apply the cosine rule to triangle OAB, we can see that our resultant force will be equals to the first force, in this case, as 5 squared, the second force, 8 squared, minus 2 first force, second force, cos 120 degrees. That is 180 minus what? The angle between them, which is theta, 60. Alright, what do? We remember, we know this is 25 plus 64 minus, this is 10, so, okay, let me just make it, here become plus 80 cos what? 60 degrees. We mentioned that this angle is actually 180 minus 60. And as a compound angle, if you do it, you get here to be negative what? 60. We need to come and cancel this to make it positive. You can feel free and use 120 direct in the calculation. That will also not be wrong. So I should be having r squared equals to, this is going to be 85, I get, no, 89 plus 80 cos 60, 0, 30, 45, 60 cos, that will be half. So r squared equals to 89 plus 80 times what? Half. 89 plus what? 40. This will be 20 here, 129. So your r will be equals to root 129. 121 will be 11. So 11 point something. And that will be giving you 11.36 So we have 4 Newton. So this will give you the magnitude of the resultant what? Force. But we have found that we are looking for the direction also. The direction is the theta here. So we are going to use sine rule. Here, applying the sine rule to triangle OAB, still we know this will be over sine of this. I should be having 5 Newton over sine theta equals to R, which we found as 11.36 over the sine of the angle 120. We can still use 60. I think that was what the formula gave us, but we can use 120 as well. But let's go. So this means that my sine theta equals to 5 times this, 5 sine 60, which I think, okay, we are using calculator, so let's leave it there. Then divided by 11.36. This multiply this, this multiply this. So I can just say that my sine theta equals to whatever value I have with that fraction. And this will be giving us 0.38117. So now let's go for theta, which is going to be the sine inverse of 0.38117. Let's see that on our calculator. And that will be giving us 22.41 degrees. So if that is what we have, remember this theta is just here. So we can say that the angle, the resultant force made with force 2, the force of magnitude 8, is going to be 22. But we are asked to find a direction. So the direction of the force is always measured from the north. So from here all the way to this place is 190 minus the theta will give you that value. So we can conclude and say, therefore, the magnitude and the direction of the resultant force will be the magnitude 11.36 Newton. The direction is going to be 90 minus 224100. So we have, so we are going to have 67.59 degree. Now this is the direction of the resultant force itself, but this is the direction or the angle the resultant make with one of the force that is what on the x-axis. All right, I think this also gives some clarity between the first or the previous 2 episodes that we have. Here, the angle and the direction of the magnitude is provided. So this makes a difference between the previous 2 examples. Like the video, comment your thoughts, share, and subscribe.